In this video, we're going to solve this quite complicated pair of simultaneous equations, and we're going to do this using substitution. Now, what we want to do is rewrite one of these equations to make x or y the subject of the formula. Hopefully, you can see why I wouldn't want to rearrange this second equation to make x or y the subject, because this looks horrific. However, it's quite easy to rearrange this equation to make x the subject. All I need to do is subtract 2y from the left-hand side, and that would give me x on the left. And I need to subtract 2y from the right-hand side, and that gives me 7 minus 2y. Now I've got an expression for x that I can substitute into the second equation. So that second equation starts off with x squared, which I now write as 7 minus 2y all squared, plus 2 lots of x, so that's 2 lots of 7 minus 2y, plus y squared plus 2y equals 23. Now I'm going to expand these brackets here and here, and that's going to give me 4y squared minus 28y plus 49 plus 2 lots of 7, that's 14, plus 2 lots of negative 2y, which is minus 4y here, plus y squared plus 2y equals 23. Now I'm going to simplify the left-hand side, and I'm also going to subtract 23 from both sides. That's going to give me a total of 4y squared plus y squared, which is 5y squared. I've got minus 28y minus 4y, so that's minus 32y, plus 2y means I've got minus 30y, and then I've got plus 49 plus 14, that makes plus 63 so far, and then I've got to subtract 23, so that just means I've got plus 40 on the left and 0 on the right. Remember, I was simplifying this by collecting like terms and also subtracting 23 from both sides. Now this is a quadratic equation. Each of these terms is divisible by 5, so I can divide both sides of the equation by 5. That gives me y squared minus 6y plus 8 equals 0. And I can factorize this into y minus 2, y minus 4, and that equals 0, which means my solutions to this equation here are y equals 2, y equals 4. Now we haven't finished. Remember, to solve these equations we need to find the values of both unknowns, x and y. Fortunately, it's now really easy to find the relevant values of x, because I've got an equation here where I've made x the subject. I've got x in terms of y. So if y is 2, then x would be 7 minus 2 lots of 2, so that's 7 minus 4, which is 3. And that means x equals 3, y equals 2 is one solution set, and my other solution set is going to have y being 4. If I substitute that into here, I get 7 minus 2 lots of 4, and that means we've got 7 minus 8, which is negative 1. So x equals negative 1, y equals 4 is the other solution set. So this pair of simultaneous equations has two solution sets, and it's important not to mix and match your sets. So x equals 3 goes with y equals 2, and x equals negative 1 goes with y equals 4. You can't mix and match those.